All right, guys, here's what we're going to do. We're going to keep going with this idea of simplifying expressions where you have a radical in the denominator. And you have to rationalize the denominator. You have to get that radical out of the denominator. Get those radicals out of the basement. So here we go. I immediately take a look at it and go, okay, well, I know I need to use the quotient property to do the square root of a to the ninth over the square root of b to the fifth, and I take a look at it and recognize my index is a 2, which means this is really, really easy. All I have to do is multiply top and bottom by whatever is down here. So we'll do that. We'll multiply top and bottom by the square root of b to the fifth over the square root of b to the fifth. Oh, let me slide a little bit. Okay, here we go. Multiply, numerators multiply denominators. Here we go. So I'm going to have the square root of a to the ninth, square root of b to the fifth, equal to the square root of a to the ninth, square root of b to the fifth. In the bottom, square root of b to the fifth, square root of b to the fifth. Anything times itself is going to be the square root of b to the fifth squared. Well, square root and square cancel each other out. You're going to be left with just a b to the fifth. So my next step, actually, let's do two things in the next step. Not only will the square root and the power cancel each other out and be left with a b to the fifth, but my index is a 2. 9 is not divisible by 2, but I can split that a up into something that is divisible by 2 and something that isn't. 5 is not divisible by 2, but again, I can split that guy up. So let's go ahead and do all of that. So I'm going to have an a to the 8th times a, and I'll take the square root of that. And then I'm going to have a b to the 4th times b, and I'm going to take the square root of all that. And that's all going to be divided by a b to the 5th. And you're left with that b to the 5th because the index and the power are the same and they cancel each other out. So there we go. Well, 8 is divisible by 2, so I wind up with an a to the 4th. I don't need absolute value because 8 is even and 4 is even, but I'm left with the square root of a. I'll get to that in a second. 4 is divisible by 2. I'll get a b squared. I don't need absolute value because it's even, and I'll be left with the square root of b. Well, I was left with the square root of a and a square root of b. Since I'm taking the square root of both of those, I can just put them together. So the square root of a, b, all over b to the 5th. And once again, I have 2 b's in the top, 5 b's in the bottom. 2 of the b's in the top will cancel with 2 of the b's in the bottom and leave you with 3 b's in the bottom. So I'll have a to the 4th. Oh, sorry, that is a terrible a. Hold up. I can do better. A to the 4th times the square root of a times b all over b to the 3rd power. And that is going to be as simplified as you can go. You've gotten rid of the radical in the basement. You've canceled everything that you can cancel. You're simplified. Next. Okay, well, we got ourselves another good one here where our index is not a 2. I have an index of 5, so we know we're going to have to do the slightly trickier one. Let's run through it together. A little bit extra practice here and see how it goes. First things first, I'm going to split this up as the 5th root of 3 and the 5th root of 4y. All right, well, we remember, right, if the index is anything other than a 2, I'm going to multiply top and bottom by the same nth root. Since it's a 5th root, top and bottom we multiply by a 5th root. So it's going to be a 5th root and a 5th root. But what goes under the radical symbol? Well, remember, we're going to do n, which is the index, minus x, which is the power. Well, the 4 is to the 1st. 5 minus 1 is 4. So I'm going to need a 4 to the 4th in both of these. 4 to the 4th 4 to the 4th. Okay, and then n minus x, n is the index, x is the power. Well, this y is to the first. So it'll be 5 minus 1, which again is a 4. So it'll be a y to the 4th and a y to the 4th. Okay, here we go. Multiply these guys together. It's a fifth root, I can put everything together. 3 times 4 to the 4th. So 3 times 4 to the 4th times y to the 4th. And I'm taking a fifth root of that stuff, all divided by, okay, here we go. Fifth root, so it'll all be a fifth root. 4 and 4, right? 4 and 4, like bases. Add the exponents. 1 plus 4 is 5. So I wind up with 4 to the 5th. But that shouldn't surprise you. That's why we spent so much time working on figuring this out, so that that stuff will cancel, the index and the power. So I have a 4 to the 5th. I'll also have a y to the 5th. And the index and the powers are going to match so that they cancel each other out. I love it. I love it. I love it. I love it. Okay, here we go. 4 to the 4th power times 3 is going to be 768. Well, 4 to the 4th is 256, which I would then multiply by 3, which is going to be 768. So 7 y to the 4th, and I'm taking a fifth root of that. And again, there's nothing I can do with this y to the 4th. 4 is not divisible by 5, but there's also no way to split that guy up into something that is divisible by 5. So it's just done. There's nothing you can do to it. In the denominator, the index and the powers cancel each other out, and you're left with a 4y, and that is as much as you're going to be able to do. Actually, hold up. Now that I'm thinking about it, I think 768, I don't think 768 is a perfect fifth root, but I might be able to split it up. So, 1 second, because I could totally see me doing one of these to you guys. So, let me do a little bit of quick work here. I got a calculator with me. 768 is divisible by 32, which gives me 24, and 32 is a perfect fifth root. Okay, so actually here, this is awesome. I'm really glad I did this. 768 is not a perfect fifth root. However, 768 can be broken up into a 32 times a 24. And guess what is a perfect fifth root? Yeah, 32. It turns out that 2 to the 5th power is 32. So, we're going to go ahead and do that. Let me slide up a little bit so you can see this as I go through it. The fifth root of 32, I just said, is a 2. Again, 24 is not a perfect fifth root, so then I'll have the fifth root of 24y to the 4th all over 4y, and one last step, right? Because now what happens is the 2 and the 4 are going to reduce, right? The 2 goes away, you're left with a 2 in the bottom, and so you have the fifth root of 24y to the 4th all over 2y. And that's going to be as far as you can go. And I realize it's just going to take a little bit of getting used to. It's definitely going to take some work with a calculator, which is why you should have a calculator with you when you're doing these. I do not expect you to know, right, that 768 is or is not a perfect fifth root, right? Just keep in mind that you may be able, or you're going to want to check. You're going to want to check and see if 768 is divisible by any perfect fifth roots, right? In this case, it happened to be divisible by 2 to the 5th. And so it wouldn't take you very long. It'll take you a couple of seconds to run through and check and see if it's divisible by any of the perfect fifth roots. And actually, in fact, let me just explain to you how I would do it. What I would do is 2 to the fifth, which is equal to 32. And check to see, is 768 divisible by 32? It turned out it was. If it wasn't, I would then do 3 to the fifth, which is 243. So I would check to see, is 768 divisible by 243? If it is, then you would go ahead and split it up. If it isn't, check 4 to the fifth. 4 to the fifth, nope, 1024, which is bigger than 768, so obviously it wouldn't be divisible by 1024. So anyway, actually it would only take you a few seconds to check it. Do 2 to the fifth, 3 to the fifth, check both of those. Is 768 divisible by either of those? If it is, then that means you would be able to simplify it further like we did. Once you get to it, right, if it's not divisible by either of these, it can't be divisible by this one, it's too big. If it's not divisible by either of these, then it's as simplified as you can get. There are no perfect fifth roots that go into that number. So do please take the time. You will need to simplify these as far as you can for me. I do expect you to be able to simplify these, and that's how I would do it. Just do a quick check of perfect fifth roots, or perfect whatever roots, depending on the problem that you've got, and then just check to see if what you've been given here is divisible by any of those perfect roots. If it is, you can further simplify. Okay, guys, that takes care of this idea, or this, what is the word I'm looking for? This technique of rationalizing the denominator to simplify radical expressions. So what we're now going to do is move on to the second objective, which is adding, subtracting, multiplying, and dividing radicals. So head on over to the next page of the notes, and I'll meet you guys there.